Hey, this is OXDF, and today we're doing day 6, 2023, Advent of Code. Wait for it. So lots of story as usual. The input's going to look like this. We're going to have 2 rows of data, or yeah, 2 rows, 2 lines. And there's going to be space-separated numbers. So each of these pair up, so 7 and 9, 15 and 40, 20 and 30, or 30 and 200. Basically, we have a race where I get to spend some amount of time prepping my boat, and then I let it go and it races at a certain speed based on the amount of time I prepped for the remainder time. So if the time is 7 seconds and I spend 3 milliseconds, whatever, 3 prepping, that means my boat will then move at 3 per second. And so because I prepped for 3, there's 4 seconds left. 3 times 4 is 12. I'll go 12. And these distances are the current world records. So I need to figure out how many different ways I can beat the world record. So, for example, in the first race, they show us that holding the button for 2 milliseconds will give us 2 per second, times 5 is 10 millimeters, which is longer than the record. 3 will give us 12, 4 will give us 12, 5 will give us 10, 6 will not. So there's 4 different ways, 2, 3, 4, and 5, that are better than the current record. And so that's the number I get from this line is 4. If you do that for all the other races, you get 4, 8, and 9. You multiply those together, and you get your answer. So I think that'll make more sense as we do it. Let's go ahead and jump in. I've got my VS Code here. I'll use my GenDay script for day 6. And here we are. And let's see. We're going to go ahead and add, oops, didn't mean to do that. Add ex.text here and push this in. Now, we should do an input review. My assumption was that this is going to be way too big to do, probably in part 2 it's going to get way too big. But we can't, we don't want to just brute force over, 53 possible seconds and figure out which ones calculate, a time slept, and, figure out how long should we push the button, check each one basically, right? We don't want to check, what if I hold it for 0? What if I hold it for 1? What if I hold it for 2? Because that'll go too slow in part 2, I feel like. So we're going to solve this smarter, and that's just using a quadratic equation. So we can start to say, let's see, let's put a block here. The amount of time, the amount of space you travel. So let's say hold the button for b seconds. So that means we're going to be moving for t minus b seconds times b, because that's our speed is b. So the question then becomes, if we're going for t minus b seconds and we want to be greater than d, which is our distance input, and I might even go ahead and just grab this right here, so we have it. And now if we want to solve this out a little bit, we're going to get negative b squared plus t times b minus d is greater than 0. And that is a simple quadratic equation. Like, we can solve that. So I'm going to do it that way. We're going to do it that way. Let's see. So we need to parse some lines here. We're going to read lines in here. In fact, we don't even need to, let's see. So we're going to come down here. We can say times this equals L for L in lines. And then for each line, we are going to split it on that and take the second one. So we're basically going to get this block right here. And then we will, I'm going to go ahead and strip it here because I don't know if having these extra spaces here is going to cause me problems. So that'll remove the space on both ends of the line. Then I can split that on nothing. And if you pass nothing to split, it will split on multiple spaces as if it's one space. And that's kind of cool. So that's now that'll give me multiple spaces here. And then I need to take that and pass it into, let's see, list map int. And so that's going to take each item there, apply the int to it, and then create the list. So I'll have 2 lists come out of there, and that should be time and dist. And let's just, we can do a quick test here and do python -i day 6 example. And if we do times dists, we've parsed it good. So now let's just do a def solve count wins, something like that. and we're going to take a t and a d. And so what we need to do is calculate a quadratic formula. So we're going to have a equals -1, b equals, so if you remember, this is going to be, so a is this right here, the -1, b is this t right here. So we're going to go call this t. I guess we need to do 4 like this times this t comma d in zip times this. So that's going to give us the corresponding pairs. So we can then say a equals -1, b equals t, c is equal to -d. And then we just need to do √1 equals, so this is -b, this is -b plus the square root, which we'll do as power, comma, 0.5. The square root of b squared minus 4ac. So b times b minus 4 times a times c. Excuse me. All over 2a. Divided by 2 times a. I think that's right. And we can do √1 and √2 is -b minus that. I always forget. Let's see. I guess we want the -1. Let's run this right here. Print √1, √2, and then we just need to do what I call it. Count wins times this. Let's run that and see what happens. Okay, so we're getting answers here. I can't remember if these are right or not. Let's see. Okay, so first of all, we're getting real things. So we need to round these up or down. So let's do import math, and we'll do math dot seal to round this up, and math dot floor to round that down, and then really what we can do actually, I shouldn't be doing this. Hold on. Let's just do this. Solve quad t comma d. We're going to just solve a single quadratic here. I don't need to solve the whole thing in one function here. So now I can say return √2 minus √1. I think this is cleaner. Now we can come down here and say t comma d for t comma d in zip times this, and then we're going to do solve quad on t comma d, and we'll do sum on that, and we'll say part 1 equals sum of that. Oh, it's not the sum. It's not the sum. It's the product. I think there's a math.product, right? Math.prod. See if that works. Let me get rid of the dash I. 210. That's not quite right. Let's go back up here and do print √1, √2. We could probably debug this, but this is faster. So let me pull up the things we're looking for here. We will go to 2, 3, 4, and 5, so that's right. We definitely need to add 1 in here. Let's save that and run again. Because 2, 3, 4, and 5. 5 minus 2 is 3. We actually want 4. 352. I think we're too big now. We need 288. So we should be multiplying 4. So that's right. 8. 11 minus 4 is 7 plus 1 is 8. And 9. 10. You know, that is wrong. Okay. So we need the time to be faster. But in fact, we have very equal roots here. So we're actually tying. We're counting the ones where we tie, and that's not going to be it. So we need to take account for that. Let's see. 4 are in √1, √1, √2. if int r equals r, if the integer value of r is the same as r, then r plus equals 0.1. That's not right. We need to do, this is gonna be dirty, but I'm gonna do, before I do math.ceil, I'm going to like add in a very small number. Just enough that if it's an actual number, we move ahead. And same thing here, I'm gonna subtract that very small number. This is messy. There's probably a cleaner way to do that. But if we run this now, we get 288, which is the answer. And we get an answer here. That's right. Sweet. Part 2. Okay. I'm going to pause real quick while I read this. Okay. So basically what they're saying is there's some mistakes in the data. All these spaces here are not spaces. So this becomes 71,530. This becomes something here. Well, let's see. What's our input data look like? So we're gonna have 1, 2, 3, 4, 5, 6, 53 million. We could loop over. That's kind of actually disappointing because I feel like we could actually just brute force this and it would take like less than a minute. But our solution is going to be better, so we're still going to solve it faster. This is going to be very easy. We're going to say solve quad, and t is going to be times. Do join. I might have to convert these to strings first. But we'll try this right now. That join diff part 2 equals. I think this is going to fail. Let's try it just to be sure. Yeah, okay. We're going to do string t for t in times. And we'll do, oh, we don't even need the string d for d in diff. We don't need those brackets. We just make a generator and then pass there. I think this will work. Oh, we didn't like this. Oh, we got to go back to an int. Int. So basically, we turned them all into strings. We joined them together, make a string. We now got to convert it back to an int, and we get answers. Too many prints in here. Let's get rid of this. That solved me. Part 2. Solved. Honestly, kind of disappointed. I wonder if we could try it real quick. Let's see. What if we do def count solutions t comma d, and we're just going to say for I in range t. So we're going to start. Basically, we're going to start counting up. We don't need to actually worry about when t is equal to t, when the I is equal to t, because then we'll hold down the entire time and we'll not have any time to move. If, and so what's our equation here is right here. So if, so I is the number, I is our b here basically. So we'll say t minus I times I is greater than d. That's it. Let's just do that. So we're going to do 1 for I like this, sum, return, like that. So basically, we're going to loop over all the t's. If it works out that that's greater than d, then we're going to add a 1 to our list. We're going to sum those up and we're going to return it. So now we can come down here and solve this with part 1 equals math.prod. What do I call this function? Count solutions t comma d for t comma d in zip times comma dist, and part. Better grab this. Part 2 is equal, and I just need to change this to count solutions. If we run this, might check it on example first. That still looks right. Run the. Let's do it with a time, and see how long this runs. Part 1 solves instantly, so it solves the whole thing in 2 seconds. Is that the right answer? 422, 50, 895. Where are we? 422, 50, 895. Yeah. So I feel like in theory they tried to make it so I couldn't just do a stupid brute force, but the brute force works as well. So, all right, I'm gonna call it here. Much easier than yesterday for sure. Thanks for hanging out with me today, and I'll talk to you tomorrow.